Alright, so this is a demonstration for Lab 2. If you see here, we got the potentiometer hooked up to 3 volts and ground, middle pin there going to A4 for my analog to digital converter, and then across here to a digital pin 12, I have the output for the LED with PWM. And if we go ahead and reset, we should see that on the screen up here we get it pulled to a random year, or asked to input a year. And if I put in today's date, after that's done, come back to the LED. LED strobing at a preset 10 Hz, 50% duty cycle. And as you can see, as we turn the pot, it does nothing to the LED, changes nothing until we press the button on the board for the first time. So you can see the frequency initially changes. As I turn the potentiometer down, it gradually changes the strobing effect of the LED. You can see it kind of stays constant there for a second as it's changing the value in the timer. Once you get your hand off the potentiometer, it flattens out and stays at a frequency. Go adjust it back up again, and I did limit it from a range from 0 to 6, or 1 Hertz to 60 Hertz, just by scaling the analog to digital converter output. Press the button again. Now we can look at duty cycle. As I turn duty cycle down, you can see it gets a little dimmer. As it goes all the way down, it turns off. Crank it all the way back up. As we turn it all the way up, it seems constant as the duty cycle is almost nearly always on. Try to find somewhere back in the middle. Pick a better frequency for this to happen. Turn frequency down, it should be a little more obvious. Go back to duty cycle. So that's a minimum duty cycle there. Scale up. You can see that it's on for longer now. As you go even higher up, the on cycle is longer than the short cycle. And then it's nearly constant, if not constant, when it's all the way up. So that's that. And while we've been doing this, we've been outputting every 30 seconds the time and date.